Okay, this is a 45, 45, 90 triangle worksheet. This is problem number 10. So it gets a little more complex at this point. So remember, this is your template for your 45, 45, 90. You have two sides that are the same. And then the hypotenuse is root 2 times whatever the sides that are the other two legs. Okay, so the hypotenuse is one of the legs times root 2. So in this situation, one of the legs is already 3 root 2. So in order to get to the hypotenuse, we have to take whatever the side length is and multiply it by root 2. So if it's 3 root 2 already, then 3 root 2 becomes 3 root 2 times root 2. So I kept the whole equation balanced. When I do that, I get 3 root 4. Okay, so 3 root 4, I guess, on both sides, which is 3 times 2, which is 6. So both of these end up being 6. So x ends up being 6. And then y is the same as that other side, so that's 3 root 2. All right. Okay, in this scenario, problem number 11, 45, 45, 90 again. So this angle's 45 by no choice, that's 45. These two base angles are the same, so the sides opposite those angles are the same. So in this case, x equals y. So I can either do x squared plus y squared equals 4 squared. And since x equals y, that becomes x squared plus x squared equals 16. Combine your like terms, 2x squared equals 16. Divide both sides by 2. X squared equals 8. X is equal to the square root of 8, which breaks down or factors down to 4 times 2, which factors down to 2 root 2. The other method for solving this is if you consider that in our template, this is A, and then that makes A root 2 this side. So you could say the side that is A root 2 is equal to 4. So then to get A, you would divide both sides by root 2. So A equals 4 over root 2. Can't have a radical in the denominator. So you have to rationalize by multiplying by whatever's in the denominator over itself. And that changes this top, multiplying straight across to 4 root 2 over root 4, which is essentially 2. So we have we have 2 root 2. 4 divided by 2 is 2. In other words, this becomes that, and they're the same. So either method works for those problems. 12 is identical to 10, same exact process, different numbers. And then finally, for problem number 13, if you superimpose the template up top here for the 45, 45, 90, this is kind of the key to everything with these, to understand that template. This side would be the side that's A, which is equal to this side, which is A. And then this side is the side that's A root 2. So if you go on the previous problem, you can find a pattern. See how this side was 4? Well, this side ended up being half the hypotenuse times root 2. So this would be 4 divided by 2 is 2 root 2. So if this were 10, this would be 5 root 2. This were 40, this would be 20 root 2. So in this case, it's half of whatever this number is. So 5, half of 5 is 5 over 2, root 2. And that's the answer. It's not a nice, clean, wholesome answer that we're used to, but that's the solution. So let's walk through it algebraically. We can do this. The part that is a root 2 is equal to 5. Divide both sides by root 2. This is 5 over the square root of 2. So I divided both sides by root 2. Rationalize the denominator. This multiplying straight across becomes 5 root 2 over root 4, which is 5 root 2 over 2. Relationship there. The other way to solve that problem is, you know that, I can scoot up just a little bit here. So, make some room here. If you know that x is equal to y, and also that x squared plus y squared is equal to, in this case, 5 squared, substitute your x and y values. X squared plus x squared is equal to 25. 2x squared is equal to 25. Divide both sides by 2. X squared is equal to 25 over 2. Square root of both sides. Remember, in this scenario, this is x. This is 25 over 2, which is equal to square root of 25 over the square root of 2. 5 over root 2. Rationalize. 5 root 2 over root 4, which is 2. So we've got a solution there, a solution there, a solution there. The key to this whole thing is to identify these patterns so you never have to do all of this work.